Being here today to explain about the fiber optics, how it works, and how many types of the fibers, and what are the losses, and how we should test the fiber. And we will discuss all the things one by one. So first of all, I would like to explain about the single mode fiber. So single mode fiber is also, it comes in OS1 and OS2. It's 9125 micron. Basically 9 is inner dia, 125 is outer dia. So if someone want to check the cable, if it is written on the cable 9125, whatever the color, you should know that it is a single mode fiber. In the multi-mode fiber, there is two type of the dia, 62.5, it called OM1, and it was some years before it was widely used, but now 50 micron. In 50 micron, this called 62.5 called the OM1. In 50 micron, we call it OM2, OM3, OM4, OM5. So basically, the bandwidth has been increased in this one. In OM, this is the latest one. So I will explain one by one things regarding the losses, how many type of the losses and how fiber work. This is basically I explain when the laser enter, the fiber optic enter, it penetrate in the, this is a tube. Tube is a glass or the fiber, so it can penetrate in this way, zigzag, zigzag, zigzag. So it strike here on the wall of the fiber. Okay, so there are many things I will explain down. How many types of the losses? This is the way how laser work, and I will explain the losses now. So we have number one, supplies loss, insertion loss or connector loss, micro bend, observation or scattering loss. Okay, so I will explain here in I made one drawing over here, so make it close up. Now this is, for example, one patch panel. So fiber optic patch panel, this cable comes inside the panel. It should be tied here with the strength membrane, should be tied in this point, and then it should be tube one circle inside. We should leave it inside, because in the maintenance purpose later, if you required fiber or something happen, you can use this tube. So then you bring the tube up to the cassette supply tray over here. So you give the 2-3 roll inside here, inside the cassette, and then there is the pigtail. So you make also some roll of the pigtail and supplies over here. So this supplies loss, generally supplies loss and standard in the world is a 0.1 dB. So I just mention over here point, this is a supplies over here, pigtail 0.1 dB. Now we have the adapters, 1, 2, 3, 4 adapters over here, 4 fiber cable I draw. Then there is a connector loss. Connector loss we cannot take directly with the OTDR. So we have to put the launch cable. We have the 2-3 reasons to put the launch cable. So I will explain one by one. So when you will put the launch cable, then you are able to get the insertion loss. Without putting this one, you cannot get the insertion loss. And for example, if I explain it over here, 0.5 dB is insertion loss according to DIA standard SC connector. So in this 0.5 here, in this 0.5, it is also the loss of the supplies also, which is 0.1. So when I am talking about the 0.5 dB, so it also includes the loss of this one. So when this loss increase, for example, we require 0.5 dB loss here with the connector with the launch. And if this fiber loss increase, so there are the many reasons. Number one, your pigtail is dirty or your pigtail is faulty, adapter is dirty. Then if you have, this is splice loss, if you have not done the splicing proper here, fiber is not proper cut over here, or you have the electrodes is not good enough, so then it can cause loss. Then it causes mismatching of the fiber. Sometimes fiber is 9125, even pigtail is 9125. Both are single mode. But sometimes what happen, you connect this one, you splice and test, there is a problem in the mismatching. So one factor always we have seen many places this one. Some fiber of the corning mismatch with the other pigtails, or other pigtail mismatch with the calm scope, or some it happens it happens sometime. And one we have another thing, splice protector, because when you use the splice protector with heat shrink, you can say, so this come 45 and 60 mm. So if this is not good quality, so the rubber will be, when it is heated, so rubber will catch on the end of this fiber, and this will give the loss. So this factor is also considerable. Now I will explain another thing. For example, somebody get the loss over here. Suppose loss is here, no 0.5. If this loss come here, for example, this 2.5 dB. So this 2.5 dB due to many reasons. First of all, we will check the connector, clean the pigtail, change the pigtail, resupplies. If your electrode is good, you know your electrode is good. So everything is good, and even though it is not coming down, so it is showing the same value, then it has to be tested from the other side. I have shown over here. So when you will test from the other side, the value will come in minus 0.0003. I give example. So you add this one plus this one, your value should be less than 0.5 dB. So that is why we test from the other side. But some clients they say we need one side because the cost and the time go very high when you will test from the other side. So I for example, if I make one panel over here, this is a launch cable OTDR, and this is two supplies, and this is another launch over here. So in this case, one reason which we use the launch due to get the proper inertial loss. Number two, the dead zone, normally OTDR has a dead zone, previous OTDR has a dead zone of 50 meter. No our OTDR, it is 1 meter, 2 meter is a dead zone of that. Even though we connect the launch to get the proper length, and then if there is a problem nearby somewhere, sometime we have the problem exactly after the panel, suppose 1 meter, 2 meter. So to verify the exact problem in exact place, we must have to put the launch over here to get very near fault. Second thing, if cable is big enough, for example, if cable is a 288 fiber, so we are testing from here 1 to 288. If fiber is swab, for example, 2 number fiber come number 7. When you will do ordinary test, it will show the length, it will show everything. But when when you will connect into the system, it will not work because the other 7 it will might be changed with some other connector. So to avoid this one, we put another launch for that one, but it takes too much time and very high cost for that one. So we just consider no for simple testing with one side with the one launch cable. Okay, so another thing I have explained how we know that our testing is good enough. So for example, if we have a 10 kilometer cable like this one and we have 2 giant over here, we put OTDR over here. I shown this one 0.5 dB. This loss I told 0.1 dB, standard is in the word 0.1 dB, and then connector loss over here. So formula, there are the 2 lambdas, 1310 and the 1550. In the 1310, the formula is 0.35 multiplied by length in kilometer plus supplies loss plus connector loss. So I calculated here 0.35 multiplied by 10 because it is 10 kilometer plus 0.1 into 2 because we have the 2 supplies. So it is plus 0.5 into 2 because we have 2 connectors. So I have calculated here 3.5 plus 0.2 supplies loss plus connector loss of both end is 1. So 1.1 loss should be for this segment, for this span on a 1310. In similar, in the 1550 formula will be this one 0.25 into length in kilometer plus supplies loss plus connector loss. So we can calculate the same way. Now we are talking about the fiber optics. So we have G652D, G652A, G652 G654, G656, many types. In other video I will explain each type of the cable, why we are using. Normally G652D is being used for the long haul, the long distance, okay. And if you see here OS1 and OS2, both are the single mode. This is for the shorter distance and normally it is tight buffer cable we use. OS2 is for the longer distance we use. So both are the single mode, but OS2 is for the longer distance. And these are the types of the cable, and we will explain it in other segment, and we will explain also the bandwidth and the dia and the transmission of the multi-mode fiber in my next video.